All right, welcome to Math 107. We are pre-calculus. However, our textbook is an algebra and trig textbook, and I selected that because it has a little bit more detail than a pre-calculus book. First of all, today, this is the lineup, and I always hope that I can cover all of this. I want to introduce you to your textbook that you're going to pay a lot of money for, but we selected this textbook because we think it is very user-friendly, good examples, and I'm going to point out some things to you in your textbook that you may not notice unless I do. I also ask you to get a student pack. It should be actually packaged with your textbook when you purchased it, was it? Oh, it's supposed to be. Okay, well, I still want to go over and tell you those things that are in the student pack. I want to show you on the web where I'm going to communicate with you, and that's through Vista. This is a new version of WebCT. And then your homework will be submitted by WebAssign, and I'm going to go there and show you an example of that. And then just sort of tell you a little bit about the course syllabus. So I want to do a little bit of general. Don't let me forget to ask you guys if you have any questions after I go over that. Then we're going to jump into functions. Now notice that we're going to start in Chapter 2, Section 2. And the first part of the book is review. And then Chapter 1 is on just expressions, but this is a course that starts with functions. So you have a lot of material up front in your textbook if you're weak in an area so that you can go and practice. And there's objectives listed with this, and this is in the textbook. I'm going to show you where all of this is, but I just want to get this in front of you. From Section 2.2, we're going to be doing objectives 1, 2, 3, and 4. And then we're going to move into Chapter 2, Section 3. This is being videotaped during summer school, so we have a nice 2 hours. So it's like covering at least 2 classes in a one period. And so we'll look at objectives 1 and 2. And we'll see if we get into section 2.4. I always like to be prepared. And just know, too, that sometimes when we go into some material, the next day I also back up and go over it again or add to it or something so that it's not like maybe today is new material and tomorrow you never hear about what we just did. Now, one of the reasons I think that we may be able to get through 2, 3, and 4 today is because I don't believe you would be in a pre-calculus course if you haven't already had some algebra background. So therefore, functions are something that I hope you know something about. All right, so the first thing we want to do is look at the textbook, and let me point out a couple nice features to you. I want you to wear this textbook out while you're here. Well, the first thing I want to point out to you is the inside cover. And it lists some of the features in the textbook, and it tells you, of course, the benefits and all this good stuff. But there's a couple things that I want to show you. At the beginning of each section, it's going to tell you the learning objectives. One of the things I like is it has a preparing for this section. So if you don't have the basic skills, which I usually do like warm-up problems if I were teaching a class with a different kind of book, well, the preparing for this section is going to be like your warm-up problems. What from your past do you need to be successful in this particular section? The thing I really like are these little calculus icons. Let me move this over a little bit. Calculus icons. This is a pre-calculus course, and the purpose of this course is to prepare you with the skills that you need so that you will be successful in calculus. So when we designed this course, we said, let's be sure we're focusing on those things, those pre-calculus skills that you need to be successful in calculus. So you'll notice that we do a lot of calculus icon type problems right here. And there'll be problems in the exercises. So when you get ready to study for a test, pretty sure that if it's a calculus related topic, it's going to be there. I like it that it also has a little pencil by some of the problems that says, okay, I just showed you an example. Now, the little pencil says, go to the exercises, and here's a problem that's almost like the example so that you can practice it. And they have little warnings, etc. Let me just flip through I'm just going to jump to Chapter 2 in the book and just point out some of the things I was just showing you. I have little stickies all over the place, so I don't forget to show them to you. Okay. Let's see. The first, I'm in Chapter 2, Section 2, because actually this is where we're going to begin the course. It has a preparing for this section, and here are the topics from Chapter 1 or the review section. That is really at the very beginning of the book. If you feel that you're weak in any of these areas, you simply go to those sections of the textbook and practice. These are the things that are needed for success in this section. Now, listed below that are the objectives. So on the sheet that I gave you, and if you're doing this by distance ed, I have the objectives listed, and for the class that's in here, you'll see that you have objectives listed. Now, each section we don't necessarily cover every single objective, but in this particular one we are, so I highlighted it. Now, what I really like about this textbook is if I want to go and spend more time, say, on Objective 2, it's very easy to find where Objective 2 is. There's where all the material for Objective 1 is, below it, and if I turn the page a couple times, I'm over on page 209 now. You see the little 2 there? This is where Objective 2 material starts. So if you know where your weakness is, you can go find where the content's set up. It's a very organized book. I love the way it is. And right above Objective 2, there's a little pencil there. What happened was you had an example 5. It worked through example 5, and now to give you one very similar, it's saying go to the exercises and work problem number 33. So it's a very readable book. Another thing that I like about the book is that sometimes it'll just give you in plain old words what they're telling you instead of the mathematical formal definition. Another part that I think they do a good job in this book is, here's an example. I'm on page 211 at the moment. Here's an example, and they really are telling you what they did in each line. So if you're having any trouble figuring it out, going from one to the next, as you work through the problem on your own instead of just reading. Remember, in math, you need to have pencil and paper in hand, and you're actually working and then double checking yourself here. And they're telling you what happened there. There's another little calculus notation. We're going to be working with difference quotient in this section. See what else I wanted to point out to you. I'm in the exercises on page 216. I'm still in section 2.2. Remember the beginning of the chapter where it says, are you prepared? Here's the objectives. Well, here are a couple little exercises that went with those are you prepared? And we're going to always, I'm going to try to remember to always start out with these as our warm-ups so that we'll know that you're ready for the section. Alrighty. And that is sort of the way it's set up. It's very organized. Here's section 2.3, preparing for the section, the objectives, etc., etc. So I think you've got a very user-friendly book, and I hope that you will totally wear out your textbook in this class. All right. Didn't you love it? Isn't that nice? The answer to that's yes. Thank you very much. Like that response. All right, the next thing that I ask to be packaged with your textbook, and I just want to point this out to you, is the student study. It's just a pack. It's a package, and I'm going to show you what's in here and try to tell you. I mean, I'm sure you can read this on your own, but I love it. The first thing that I've heard that has been helpful is when you buy this student pack, there's going to be a number up here, and there's a toll-free number where when you're stuck on a problem or you need help, you can call, and there's a live math person on the other end of the phone who will help you out. So and the hours are Sunday through Thursday, 5 p.m. to midnight, Eastern Standard Time. So Prentice Hall has hired tutors, and when you buy this packet, you can place a phone call, and there you go. Got some help. I understand that that's worked really well. Okay, the next thing I want to point out to you in this packet is a CD. And this says chapter test preparation videos. When you put this in, what it's going to do is go to the end of the chapter. Let me find the end of chapter 2, if I can find it. There is a chapter test. This happens to be page 293, and it's the chapter test. this disk has a human being working the problems and explaining them to you. So the best way to use this is you work it as a chapter test, and then, of course, the answers are in the back of the book. If you can't still figure it out, then you put in your disk, and it lets you click on the particular problem, and then you will hear somebody work the problem and explain it for you. Isn't that nice? Okay, so these are chapter tests. One of the favorite parts everybody likes, this is an algebra review. Sometimes people in pre-calculus need to go back and have some drill and practice in their algebra skills that we assume that you're already good at. For example, maybe factoring is a problem. Maybe you need to go back and review your factoring. So here is just an algebra session on factoring, removing the greatest common factor, factor by grouping, factoring second-degree trinomials. So you basically have a college algebra level book or maybe a high school algebra level book. So these are basic skills if you need more drill and practice on. Love that. This is the part I knew you'd get excited about. What is this, everybody? The solutions manual for the student. These are the odd problems. And what I like about it is you do have the answers to the odd problems in the back of your book, but sometimes you're going, okay, I don't have a clue how they got that number. I've worked and worked and worked and worked. You don't ever go here first. You work and work and work first, and then you come here when all else fails. And so what they do is, I'm just looking at, say, number 27, they show you the entire line-by-line work to getting the problem. So what you would want to do is work your problem yourself. Try to find your mistake, because we always learn from our mistakes, but try to find your mistake yourself. Highlight it if you find it, but if you can't, go to your solutions manual, and I would say that once you find your mistake, go back to your work and circle it in red so that you keep reviewing that type of mistake so that you don't keep making it. If you say, oh yeah, now I know why I missed it, and then you never make documentation of it when you're studying for the test or you're studying daily, you don't know where to send yourself to keep reviewing and practicing. So I would highlight that in red. That's my opinion. Okay, and then there's one other useful tool in here, and that's over here on the side. Let's see if I can get it over. And there's a whole set of CDs. And what is on this whole set of CDs is the author of your textbook has gone in and said, okay, I sort of expect that students will have, say, trouble with example 5 on page 273. Maybe the information I'm giving them is not enough. So therefore, I'm going to actually work this problem out and explain it as I go. So you've got your textbook, you've got the comments, but if you still were having trouble figuring out, you wanted to hear somebody tell you what they were doing, they will be on this. They picked not every single example in the textbook, but those that they thought students would have more problems with. Isn't that pretty neat? I've met the authors of this textbook. They're very dedicated to having a textbook that you will actually use and to provide you with the resources, as many resources as they can, so that you will use the book and that you will learn and be successful. How's that, everybody? Great? Any questions about this course pack?
Do you know how much it runs? How much it
It's
costs?
supposed to be packaged with your textbook and free.
Okay. All right.
Okay, so back over here, we've looked at the textbook. Now the textbook costs a lot, but it's worth it. Okay, you got your textbook, your student packet, and now Visa is how I'm going to be communicating with you. So I want to go to the website and just have you click around a little bit. Hopefully everybody in here has already done that. But let me just go there and see what I can tell you. Okay, so it's Vista, VISTA. .ncsu.edu. This is a new version of WebCT, and actually at this moment it's in the beta stage, meaning that it's not totally set up. Okay. All right, whatever it says, we're okay. So you would just go and log in. Yes, I did notice that. And you would not see all this, but I'm the instructor, so I've got a lot of courses set up here. Okay, I'm happy. Okay. All right. So when you logged in, I'm going to go to Student View. Okay, I'm happy. When you logged in, this is the view that you should have seen. There's a student orientation to it. I haven't even clicked there, but there it is. There's information sheet that's a Word document, and actually in this class I've passed that out to you. For distance ed, I'll have one set up for you. Here's the summer schedule. I've already passed that out to you. Web assigned homework, we'll click on that in just a second. And the Multimedia Center, which we have over in Harrelson 244, videotape lectures, which will probably be these, and tutors are in there. Okay, and you will notice that there should be a discussion somewhere. Just click discussions. And I'm going to set up different topics so that you can communicate with each other. I'll go back and put in a whole lot. So I'll have like a 2.2 functions. If you have any questions about material from 2.2, you put them in there, you respond to each other, and I'll go back and put in like Chapter 2, Section 3, whatever that topic is, so that you can be real specific. So what you want to do is be very careful that you put in specific questions, not like, how do you work number 7? You say, in number 7, was it asking me to solve for X, or was it asking me to solve for Y? I don't understand what the question's asking, or I know I need to do so-and-so, but then I don't know what I need to do. So put in very specific questions, respond to each other, and I'll be checking those also. Okay, I put in announcements, and here are the announcements I put in so far. As of 7/5/05, that was today, WebAssign was not set up yet. I had contacted WebAssign, and just a second ago I saw that it's up. Emails, be sure you put in your subject line MA107 because we get a lot of spam, and I'm looking to only open those emails that I recognize. I have my email address here. I do check emails once a day, Monday through Friday noon, and not holidays, okay, not weekends. Your homework questions are posted in WebCT under your discussion. Don't send specific homework questions to me unless you're not getting satisfaction there, but I'm trying to watch those. And then this, your discussion board is also a way to work with your each other, get to know each other. You will also have my grades. Okay, there'll be a grade book. It will list each of your test grades. It will list your final exam grade. WebAssign will probably not be current there because I'll probably load that in at the end. So as soon as your grade, this is where I'll keep the grade book, so you will always see what I have listed there in it. Okay? All right, so are you happy with WebCT? Good, that was the right answer. You got the hang of it. All right, I want to go back. Go back, go back, go back. Go back to the home page. Should be an easier way than this. All right, now homework is going to be submitted over WebAssign. And you have a link that I wrote at the beginning, which was webassign.ncsu.edu. But I hopefully have it on the Visa page, and you can just click here so that you don't have to have so many sites. And let me just log in. This is what you would do too. Who's used WebAssign before? Everybody? Okay. Do you wish to continue? I'm sure I do. All right, and I'm going to see if I can go to a student view so that you'd see. All right, so when you log in, you should be at this site, and this is MA107. And you have to have an access code. They give you 10 days to get it. I think that's $10. Am I correct? $10 for an access code. Okay, but anyway, it looks like they've got stuff loaded in here, but the times are not set up right yet. So anyway, we're just going to pick a section. All right, this just got loaded in just a little bit ago. I'm going to go to section 2.2. And this came from chapter 2, section 2, and it's very similar to question number 9 in your textbook. And where you see the red, that means that the textbook has a different number, but your special numbers are 3,000 and the 3. Okay? So we're just going to put something in here. It asks for a function. I'm not even going to put a function. I'll just put 3x plus, well, I'll put a function, 10. I know that's wrong. And what is the book value of the computer after 2 years? I'm going to put $30. All right, so you put your answers in, submit this question. I'm only going to submit that one. And it marked it X. I got both of them wrong. If it's right, it will give me a check mark. Once it's marked wrong, I can go in and try again. WebAssign will give you, I believe, 20 submissions. I've used 1 of 20 submissions. This is like problem number 1 because it has, if you look over in the margin, that's blank 1, blank 2. And so far I have 0 out of 1 points, and I've done 1 out of 20 submissions. So you got 20 submissions to get that question right. Okay? And again, I would keep very good notes of how you work the problem, because if you make a mistake, you want to circle it in red so that you learn from it. Okay? And so these will have due dates and times. Right now, this just got loaded in. Everything's not set up exactly right, but it should be hopefully by the end of the day. Okay? Everybody good? Questions about WebAssign? All righty. So we'll close out all of this. All right, then also if you're taking this by distance, you have just like when you went to that vista.ncsu.edu, you had a welcome letter and a schedule which has your test dates and your homework. All righty. I think we're ready to begin. We're going to start in Chapter 2, Section 2. Open my book, and hopefully you have your book open along with it. And let's look at the objectives that we're going to cover in this today. All right, we want to talk about whether a relation represents a function. How do you tell the difference between a relation and a function? We want to be able to find the value of a function. What does that mean, value of a function? We want to talk about the domains of a function, the domain of a function. And then I call Objective 4 the creation business. We're going to create new functions from two functions by adding, difference means subtract, product means multiply, and quotient division. So we're going to take two functions and create 1, 2, 3, 4 other functions. Okay? But what I'd like to do first is let's make sure that we're totally prepared for this section. So if you will turn to the end of Chapter 2, Section 2, and you have 4 quick questions here to answer. And I'll read those to you if you don't happen to have your book at the moment. The first question is, the inequality -1 is less than x less than 3 can be written how in interval notation? So I'll read you the question and you just put a response down on your paper and we'll come back. The inequality, if you don't have your book at the moment, the inequality -1 is less than x less than 3. Basically, how do you write that in interval notation? Do you need paper? Oh, sorry. See, I told you I'd be watching. Okay? All right, interval notation. Okay? Question 2. If x is equal to -2, the value of this expression, 3x squared minus 5x plus 1 over x is. So if x is -2, you're asked to find the value of the expression 3x squared minus 5x plus 1 over x. let's go to the third question. We're looking for the domain of the variable in the expression x minus 3 over x plus 4. We're looking for the domain of the variable in the expression x minus 3 over x plus 4. Basically saying, what's the domain of this expression? Domain of the variable. X minus 3 over x plus 4. Okay, and the fourth question, you're asked to solve the inequality 3 minus 2x is greater than 5. Solve this inequality for x, and then it says graph the solution. Solve the inequality 3 minus 2x is greater than 5, and let's graph the solution. Okay. Anybody need me to read one of these again? I know on the first day you don't always have your book in hand. Everybody got it? Okay, why don't you just take a second and peep over at your neighbor and see how they did. Let's see how your neighbor did on this. Because I need to know who to call on, right? I'm sure your neighbor did perfectly, and you want me to call on them, correct? How'd your neighbor do? Got one right? All right. Let's go through these together, and let's be sure that you're asking questions if you have some. All right, first of all, the inequality -1 is less than x is less than 3. That just means that x is between -1 and 3. And you're supposed to put it in interval notation. Okay, this is inequality notation. And you probably learned to do a solution on a number line. This is page 216. And you have -1 is less than x less than 3. Everybody remember when you used to do a number line, you do a -1 and you do a 3. You put an open circle at -1 and 3 and shade in between, and it just means that x is any number between -1 and 3. Everybody remember those good things? Okay. All right, did anybody ever, instead of an open circle, use a parenthesis to indicate that the -1 was not there? You've used that before? Okay, so some books, and I forgot to check to see what this book does, instead of using open circles, they'll just use a parenthesis. That means we're on the real numbers, on the real numbers, and x can be any number between -1 and 3. It could be 1.023. It could be 0. It could be -0.99999. That's in that interval. Because -2 is over here, +4 is over here. Our solution's in here. Okay, so if you had this, who can tell me what the interval notation is for this? What is it? Yeah, you just use parenthesis, -1, 3, parenthesis. Now for some people that looks like an ordered pair, but we're in one dimension on the number line, so when x is between -1 and 3, we can just use parentheses, -1, 3 as our interval notation. Okay, suppose that, let me give you another example. I didn't overly excited about that one. Suppose that I say negative 2 is less than or equal to x less than 7. Negative 2 is less than or equal to x less than 7. Notice I have or equal to this time. So here's my number line. There's 0. Here's negative 2, positive 2. Way over here is 7. How would you do it on the, how would you graph this solution? Would you put it negative 2? You put in a closed circle because the negative 2 was included. And what would you put at 7? Open circle. Okay. Now let's go back to the idea we had before. If there was an open circle, sometimes you used a parenthesis instead of an open circle. Anybody have a clue what you did when you had a solid dot? Square bracket. Square bracket. So if you look at it that way, then it's going to be very easy to put it in interval notation. What would the interval notation be? Say it. Square bracket.
Square bracket, negative 2, 7, open
parenthesis.
bracket.
Open parenthesis. Okay, let's do one more. Then I know you're the expert. Suppose that the inequality is x is greater than 3. Let's do greater than or equal to 3. X is greater than or equal to 3. Here's 0. Here's 3 on my number line. All right, so you already told me you use a solid dot. Greater than 3 means it's going this direction forever, correct? Okay. What's the interval notation? Square bracket.
3.
Whoops, square bracket. Infinity.
Parenthesis.
Parenthesis. Is it parenthesis or square bracket? Why parenthesis? All right, you can't hit infinity. There's always another bigger number, so it's always a parenthesis with infinity. Okay, we are now experts in inequalities, correct? Okay, let's go to question number 2 in Are You Prepared? Question number 2 was, if x is equal to minus 2, find the value of the expression 3x squared minus 5x plus 1 over x. Find the value of the expression. Why are we calling this thing an expression and not an equation? Doesn't have an equal sign. It's just 3 terms. It's an expression. It's not set equal to anything. All right, so it says find the value of the expression when x is equal to negative 2. What did everybody do? Okay, the correct word is substitute. My own mathematical words are plug and chug. You're going to plug in negative 2 and chug out the answer. Plug and chug. But the correct thing to say is substitute. So we have 3 times negative 2 squared minus 5 times negative 2 plus 1 over negative 2. And just reviewing negative numbers and square and all that stuff, negative 2 squared is what? Positive 4. And negative 5 times negative 2 is positive 10. And then we got a minus 1/2 here. So we have 12 plus 10 minus 1/2, which looks like that's 22 minus 1/2, which must be 21 1/2. The value of the expression is 21 1/2. Did I give you that right? Is that what matches your paper?
Yes.
I saw some of you didn't do it. You tell me it matches. All right. Can we go to number 3? Okay. Number 3. Number 3 is talking about the domain of the expression x minus 3 over x plus 4. It says the domain of the variable. Remember, the variable is something that varies, and that's your unknown. So x is your variable. All right. When it's talking about domain, we're really talking about over the real numbers. And we want to know what values for x make this expression a real number. Or is there some value for x that blows up this expression that it would not be a real number if you substituted in for x? And what is that, everybody? all real numbers except for -4 because we can't have division by 0. So my domain is x. This means x is an element of the reals, and you can just write out the words if you want to. X is all real numbers except x can never be equal to -4 because we cannot have division by 0. Very good, very good, very good. All right, that was problem number 3 in our warm-ups, and now let's go to problem number 4. Number 4, we're solving an inequality. 3 minus 2x is greater than 5. 3 minus 2x is greater than 5, and we're solving the inequality. Why is this an inequality?
It's not equal.
Okay, it's got a greater than sign in it. It doesn't have an equal to sign. All right, how do we go about solving this inequality? What are you going to do?
Get X by itself.
You need to get x on a side by itself, so you're going to solve it just like you do in an equation to begin with, correct? Trying to get x on a side by itself. So the first thing I'm going to assume everybody did was probably subtract 3 from both sides. That's called the golden rule, right? Do unto one side of the equation as you do unto the other. So we have -2x is greater than 5 minus 3, which is 2. Okay, what's the next step, everybody?
Divide by -2.
We're going to divide both sides by -2. Does anybody have an alert from me?
Switch the sign.
Okay.
Divide by a negative.
Alert. We reverse inequality sign in 2 situations. We reverse the inequality sign when we multiply or divide by a negative. And what's the other time? When else do you reverse your inequality sign? Let's look at this. 1/2 is greater than 1/4. Let's take the reciprocal of both sides. Reciprocal, what happened? Reverses the sign. Okay, so if you take a reciprocal. All right, and let's do the example with multiply or divide through by a negative. We can say that -3 is less than 10. -3 is less than 10. But if I multiply through by -1, multiply through by -1, I would have 3, and I'd have a -10. And 3 is clearly greater than -10. So the example for multiplying or dividing through by a negative, reversing your sign, or if you take the reciprocal of both sides. So watch out, be careful. So when we divide it through by -2, we're going to go ahead and reverse our sign, and we get x is less than -1. How do you check that? How do you check it to make sure you haven't made a mistake?
Plug and chug.
Plug and chug, yes. You're a fast learner. All right, so we'll just do a check. Any number less than -1, so we'll just pick x equal -2. X equal -2. And remember, when you do a check, you always go back to the original before you started playing around with it. All right, so we're going to check. We'll say 3 minus 2 times a -2. I'm just substituting a -2 in for x. I could pick any value I wanted to less than -1. I could have done -1.01. That is less than -1. And the question is this greater than 5? So we have 3, -2 times -2 is +4. Is that greater than 5? Yes, it is. 7 is greater than 5. Okay? Everybody good? All righty. That is all you need to know to be successful in section 2.2. Who needed to be reminded of something? Tell me what you missed.
in number 4, I'd forgotten about the brackets, like for the closed circles, which one to go
Okay.
for the closed brackets.
Okay, for the interval notation, when you use an open parenthesis and a closed bracket. Good. Thank you for bringing that up because somebody else probably missed that too. Something else that was missed in the warm-up that you learned. If you verbalize it, you remember it.
The reciprocal.
The reciprocal. Yeah, a lot of people forget that part about when you have an inequality, taking the reciprocal of both sides. Anything else missed? Or that was a good reminder? Nothing? Okay, we're ready to move on into the new material, and we're on 2.2 functions. And the first thing we're going to do is take a second, and there's 2, 4, 6, 8 people in here. So just pair up, and I want you together to make a list of everything you remember from the good old days about functions. Make a list of everything you remember about functions.
It's like an equation.
Don't remember much? Well, that makes me feel more needed if you don't remember much.
Remember writing F off.
Okay, well, that's a start. That is a start. So put it down. Anything you can remember. Okay, I'm feeling very needed at the moment. All right, let's start. You said you remember something about an f of x. All right, anything else to go with that f of x?
F of G. I remember doing F of like
Inverse of f. That's inverse of x.
Okay, so you remembered something about inverses, that some functions have inverses, not all. You remembered something about f of g of x.
Mhm.
All right, that's composition of functions. All right, what else do you remember? What do you guys remember over here? Reciprocal functions, like 1 over f of x. You know, sometimes a little bit of knowledge will really hurt because we're really on the basics of functions. I hadn't heard much about basic functions yet. What else? What'd you ladies?
Basically those, and then that f of x is the same as saying y.
Okay, so you're saying I'm defining y to be a function of x. Y equals f of x. Okay, alrighty. Well, I hope you have your book open, and we're going to just truck through some of the things here. Your textbook, Arthur, is very good at talking about what functions are and what functions are not. Let's just take a couple examples. Well, let me ask you a few things. Do you ever remember hearing anything about domains of functions? Domains? Okay, I thought you might remember that. And as soon as I said domains, did you think of another word? Ranges. Okay, anything else? What about values of functions? Do you remember those words? Values? Values of the function? All right, well, let me just prompt your memory. We have relations and we have functions. Relations and we have functions. Who remembers the difference between a relation and a function? Who remembers when I give you the graph of a relation, if you can tell if it's a function or not?
yes. I can't remember.
Okay, something about a parabola. All right, let me draw a parabola here. Something about a parabola.
Like it's a function if it's symmetrical, like all the points, negative and positive, match up or something like that.
Okay, that's symmetry. All functions don't have to be symmetric.
For every x, there's only one y.
Okay.
Yeah.
All right, that's what you remember. for each x, you have only one choice for y.
You do the line test.
What kind of line?
You draw a horizontal,
That's
a vertical line.
vertical line test. That's what I was wondering if you wouldn't. Vertical line test. Who remembers when you use a horizontal line test? It is confusing. When do you use a horizontal line test?
When you're doing inverse.
Inverses, right. We're not ready to do inverses yet. Like I told you, a little bit of knowledge hurts sometimes because you got a whole bunch of stuff in your brain and you're coming through. All right, so we're going to start at the very basics so far. All right, so you've told me that a function is defined when you have some type of relation between x and y. And if for each value of x, you only get one choice for y. All right, here's one of my favorite little examples. Here's an example of the number of gallons of gas that you pump, and along here is the price. Okay, this is in a pretend world, and let's pretend that you're going to pump 3 gallons of gas. And you go in the store, and the person looks at you and goes, okay, you pumped 3 gallons of gas. I'm going to charge you $3. That'd be nice. Price of gas right now is $2.15 a gallon. All right, but then you go in the store, and they look at you and go, you did 3 gallons of gas. I'm going to charge you $10. Okay? That would not be a fair function, would it? Because for 3 gallons of gas, you had to pay out Y values differently depending on how they liked your looks in my situation. But that's not the way life really is. At the pump, they tell you how much the gas is. So for the real life situation with gas, if you have along this axis gallons of gas and this price, and we'll just make it easy, $2 a gallon, which all of us would really be happy if that come on down. Okay, so if you pump 0 gallons, it's $0. You pump 1 gallon, it's 2. 2 gallons is 4. And so it should be a straight line, right? Should be. That is kind of straight. So everybody is treated fairly when there's a function, because for the gallons, which is along what we normally think of as the x-axis, you have a fair price of $8 when you pump 4 gallons of gas. Okay? So the difference between a relation and a function is a function is a relation, but it's special in that for each x there's only one y. A relation will give a correspondence between an x value and a y value. Another example of a relation, if you wanted to just look at a curve, this would be a function. A relation could be like a sideways parabola. This is the x-axis. This is the y. Anybody want to tell me what the equation for this parabola is? I'll give you, x is equal to y squared. X is equal to y. This is an example of a relation that is not a function, because for whatever this is, x at 1, when x is 1, we have a y value which is positive 1. It's not quite drawn the scale, is it? And we have a y value which is a negative 1. This is like pumping your gas and they charge you 2 different prices. I guess in this case they would give you money for pumping gas with the negative. All right. So that's an example of a relation. Okay. You told me you remembered something about y is a function of x. Okay. Well, if I want to write this, it looks like I have a slope here of 2. Remember something about slopes? Go up 2 over 1, up 2 over 1. Who can give me the equation for this line?
2x plus 1.
Y equals 2x plus what? What's the y-intercept?
0.
0. Right? In the line y equals 2x, the y-intercept is at 0, the slope is 2, up 2 over 1, up 2 over 1. All right, so instead of defining it as the line y equals 2x, you could say that y is expressed as a function of x. Y is expressed explicitly. Everybody hear that word, explicit? Explicitly as a function of x is 2x. So you say y can be expressed in terms only of the variable x, f of x equals 2x. Okay, so this is your y-axis for price, and f of x would give you the price depending on those values of x. Okay, is that good, everybody? Explicitly. Okay. All right, so there's y equals f of x. Another way of saying this is f evaluated at x. Some people think this is f times x, or you might say f of x, but you don't really keep in mind what it's saying. It says, let's take the function f and let's plug in x and evaluate it. All right, domains. Let's look at the graph that you gave me, which was the parabola. By the way, what's the equation for this function?
Y equals x squared.
Y equals x squared. Very good. This is y equals x squared. Or we could say f of x equals x squared. All right, this continues in both directions forever and ever. What would you say your domain is for this function?
All real numbers.
All real numbers, because I can plug and chug or substitute in any value for x that I want to, square, and I will get a y value, correct? I will get a y value. There's nothing that makes this undefined. All right, so my domain here is all real numbers. What would be my range here?
All real numbers greater than 0.
Okay, all real numbers strictly greater than 0?
Greater than or
Equal
equal
to
to
0.
Greater than or equal to. When x is equal to 0, the y value would be 0. So my range is y is greater than or equal to 0. The range is the y values that you get for the x values you put in for your domain. Is everybody remembering this? This is good? It's good. Okay. Suppose I want to know the value of this function at 3. What does it mean when I ask for the value of the function? The y value. Thank you, thank you, thank you. The value of the function means what is the y value? The value of the function. Remember, f of x is f evaluated at x. So when you're talking about the value of the function, you're going to plug in the x value and get the y value. So what's the value of this function at -7? Checking your multiplication without a calculator. Positive 49, -7 squared. Okay, are we good? All right. Let's take a second or two and let's find some values of functions, because what I'm going to try to lead to is one of our calculus related topics, which is the difference quotient. So we'll get there in just a second. All right, so we got our vocabulary. Let's look at finding the value of functions. Value of functions. All righty. Let's just start out kind of easy. Y equals f of x, and our function is going to be 3x plus 1. All right? Suppose I want to find the value of the function at, well, let's make life easy, 4. All right, that's a piece of cake. What is it, everybody? 13. We just say 3 times 4 plus 1, and we get 13. Okay, suppose I want to know the value of the function at minus x. How do you deal with that? Okay, so basically, wherever the x is in the original problem, you just put a parenthesis and you're going to put that number in, correct? So we will have 3, and then we'll have the parentheses plus 1, and we're evaluating at a minus x. So this simplifies to minus 3x plus 1. All right, suppose I want to know what is f of 2x. F of 2x. All right, same thing. Just go back up to the original function and put in your set of parentheses. And now I'm evaluating at, I'll do that in red, 2x. And that simplifies to what, everybody?
6x.
6x plus 1. Okay? How about the value of the function at x plus 4? Value of the function at x plus 4. Final answer, what is it?
3x plus 13.
Y'all are very good. You just put it at x plus 4 in your set of parentheses. What property did you use to multiply this out? What's it called? You are good. Distributive property of multiplication over addition. So we have 3x plus 12 plus 1, which is 3x plus 13. All right, I have to keep going till you miss something. What about minus f of x? Minus f of x. What's that going to be? All right, so it's going to be minus whatever f of x is. So we'll put a 3x plus 1 in the place of f of x. This is like saying negative 1 times f of x. This is equivalent to saying negative 1 times f of x. And when I distribute the negative, I get negative 3x. Whoops. That's a big old x. Remember your mistakes you do in red so you don't forget. Or distribute our negative 1 through this, and we get negative 3x minus 1. Be real careful when you're distributing a negative and don't do what I was just about to do. I did that on purpose. Okay. All right. All right, here's the test of all tests. F of x, y'all know what that means, right? A little more fun. 3x plus 1. And I want you to evaluate this function at x plus h. Check your neighbor out and see if they knew what to do. All right, I don't know who got it wrong. Whose neighbor got it wrong? Point to them. Because we learn from mistakes. I'll give them an opportunity to tell me all about it. Everybody's neighbor got it right? Did you continue with the same process and do your little set of parentheses? And inside parentheses, you put a little x plus h. Is that correct? And so now we have equals 3x. What was the next term?
3h.
Plus 3h plus 1. Okay, who forgot to multiply the 3 times the h? True confessions. Anybody? See, you'll never miss it again because you confessed. Yeah. All righty. Okay, this is leading to a very calculus-related topic. Calculus-related. And this is always on test and always on final exams. Does that tell you it's important? We have what is called a difference quotient. And the difference quotient, I'm just going to generally tell you what it is. The difference quotient is, pretend that you have some curve here. And the difference quotient really takes 2 points on the curve, and it's going to draw a straight line through those 2 points. And does anybody recall what you call a line that's through 2 points on a curve? Starts with a S. Secant. Secant line. Okay, it's a secant line. Okay, so you take a curve, plot 2 points, draw a straight line through it. A straight line through 2 points on the curve is called a secant line. What is called a line of best fit to the curve? that basically touches the curve in one point in a little small interval, fits the curve the best?
Tangent?
Tangent line. Okay, tangent line to a curve. But this is called a secant line. And what a difference quotient is it is the slope of the secant line. Secant line. All right, so a difference quotient is going to be a slope of this secant line. And you're going to study this in calculus, and this leads to the derivative. So it's a very important concept that you get in pre-calculus. All right, so what happens is, here is some general point x, and you know the y value goes with that, we call f of x. And what we're going to do is label this next point, but the way I do it is I just come over h units. H might be 1, 2, or 3. I'm just going to come over h units, which then means that this x-coordinate is x plus h. So this might be the number 2, and this might be the number 5. If this is 2 and this is 5, then h would be 3. Does everybody see how that works? All right, so what's the y value associated with x plus h? What's going to be the y value associated with that? F of x plus h. All right, so how do you find the slope of a line? And in this case, it's going to be the slope of the secant line. How do you find the slope of a line in general? Rise over run, which is really change in y values over change in x values, change in y over change in x. All right, here's my y values, f of x plus h and f of x. So the difference in the y values are f of x plus h minus f of x. And then the run is the difference in the x values. So you have x plus h minus x, difference in those x values. And you'll notice those x's cancel out, and you have f of x plus h minus f of x over h. And this is the difference quotient. The difference quotient is no more than a formula for finding the slope of a secant line from wherever you start at x and moving over to the next point. It's going to give you a general formula for finding the slope, okay? All right. I need to check and see if my hour is running up. It's not. Okay, keep going. All right, so we're going to play around with the difference quotient a little bit because you definitely have to know this. We're going to take a break after an hour and come back. All right, so our instructions, like on a test, would say find and simplify f of x plus h minus f of x over h given f of x is equal to, and we'll start out easy. Each one will get a little more interesting than the other. F of x is defined to be 3x plus 1. All right? Now, before we even start this, let's analyze this a little bit. All right, we're going to find and simplify this difference quotient, f of x plus h minus f of x over h, given the function f of x is 3x plus 1. All right, what's this graph look like, everybody? What's the graph of y equals 3x plus 1?
Y-intercept is at 1.
Okay, it's the graph of a straight line. The y-intercept is 1, slope is 3. So the slope is 3 over 1, so it's going to look something like this. All right, so this is a graph of a straight line. And this problem is asking me to find and simplify the difference quotient. All right? What do you bet is going to be the answer? What do you bet is going to be the answer? What is this difference quotient? Remind me visually. What is it? Slope of the
secant line.
The secant line, right. All right, so if I have 2 points on here,
It's already a secant line.
the line and the secant line are going to be the same thing, correct?
Okay.
And if you know that this is going to give me the slope of the secant line, what do you expect this is going to be when we're done?
The same as the same of what f of x is, 3x
Okay,
plus
we're
1.
expecting it to be a 3, right? In this case. All right. See how you can analyze? You could guess the answer before you did any work. All right, so we want to simplify this difference quotient. So if f of x is 3x plus 1, f of x plus h, remember where you have an x in the original problem, you're going to replace it now with your x plus h. So we have 3 times x plus h plus 1, which is 3x plus 3h plus 1. Okay? All right, so let's substitute in f of x plus h. F of x plus h is 3x plus 3h plus 1. That's my f of x plus h. And then we're going to subtract f of x. Please use parentheses so that you do not mess up. I've only been teaching about 27 years, and I know where the mistakes are made, so if you listen carefully, you won't make those. So it's f of x plus h. Whatever that expression is, use your parentheses. Make yourself a note in the margin. Use the parentheses. Minus f of x, the original function, and we're going to divide this by h. Does everybody see how I've substituted that in? See your substitutions?
That's just 3.
All right, so let's just clean up. Don't forget to distribute your negative.
So it's just
All right, so I'm going to write out every little detail. 3x plus 3h plus 1 minus 3x minus 1 over h. Okay, just distributed my negative. And now we're going to clean up. 3x minus 3x is equal to 0. Those terms are called what? Additive inverses. Additive inverses, they cancel each other out. Just working on your vocabulary. Positive 1 minus 1, 0. And so now we have 3h over h. By the way, h can't be equal to 0 because we couldn't divide by 0 or we wouldn't have an expression. Okay, h can't be 0. So since we have 3 times h over h, since h is not 0, h over h is equivalent to 1, like 3 over 3, 7 over 7. And so this equals 3. All right, so the value of this difference quotient is positive 3, but that we expected it to be that. We expected it to be it. Okay, was that my signal? I'm almost out. All righty, we're going to pick up here after our break in here, and we're going to do more with the difference quotient. All right. Talking about today, I mean, it was just so awful with that, like that when they really tell you, are we ready now? Okay, welcome back. We are continuing with Lecture 1. If you'll remember from Lecture 1, I was thinking we'd probably cover a lot of these topics today, but that's okay. We're being thorough. And we're still in functions, section 2.2, and we're still continuing our objectives. And when we left off last time, we were working on the difference quotient. Okay, just as a quick review, remind me again what the difference quotient is giving you. The slope of the secant line. And a secant line is a line between any 2 points on the curve. And the last example was just a straight line. So we knew the slope of the line and the slope of the secant line had to be the same thing. What would be the graph of f of x equals 3x squared plus x minus 5 in general? What's it going to look like? What is it? What's the shape? It's just some kind of parabola, right, that's going to open up. Just some kind of parabola that's going to open up. All right? And when we're going to use the difference quotient, we're just picking any 2 points on this parabola and drawing a straight line through it. So as you can see, it's going to have a ton of different slopes. So when I find the difference quotient, it's going to give me a formula for finding the slope between any 2 points. All right, so the thing that we want to do is find and simplify f of x plus h minus f of x over h. All right, so if f of x is 3x squared plus x minus 5, take a second and find f of x plus h. So we can just substitute in. Find f of x plus h. What do you get when you square x plus h? What do you get? You get what? X squared. X plus h times x plus h is?
What do you mean x squared plus h plus h?
Let's do our little FOIL. X plus h, FOIL, first, outer, inner, last, right?
Mm-hmm.
X times x is x squared. X times h is xh. H times x is another xh. H times h is h squared. So what is it? X squared plus 1xh plus 1xh is 2xh plus h squared. Okay, so x plus h quantity square. You're squaring a binomial. Perfect square. This is called a perfect square trinomial. Factors to x plus h quantity square. Okay, so we'll put in x squared plus 2xh plus h squared plus x plus h minus 5. All right, so let's clean this up. Don't forget that we need to distribute the 3. 3 times the x squared, 3 times the 2xh, and 3 times the h squared. All right, so when we do this, we're going to have a 3x squared plus a 6xh plus 3h squared plus x plus h minus 5. You've got to be careful, write neat enough, well, I ran off the page. Write neat enough so that you don't lose anything. All right, everybody okay with f of x plus h? If you'll get that done first before you make the substitutions, I think you'll make less errors. All right, so I'm going to do my little famous plug and chug. F of x plus h. Remember, be sure you put in your parentheses. 3x squared plus 6xh plus 3h squared plus x plus h minus 5. That is my f of x plus h. And then we're going to subtract our original function. Our original function is 3x squared plus x minus 5. So we're subtracting our original function. And we will divide this by h. Remember, h is not equal to 0. H can't be equal to 0. All right, let's go through and clean up. You hope a lot of things are additive inverses of each other, so they'll cancel each other out. We have a 3x squared, and if you distribute your negative here, we'll have another minus 3x squared. So the 3x squares divide out. Not divide out, subtract out. They're additive inverses. What else is going to disappear? The x, here's a positive x with a negative x when you distribute the negative. And what else? The negative 5 and minus a negative 5 is a positive 5. Okay, let's see what we're left with. We have 6xh plus 3h squared plus h all over h. Alrighty, how are you going to simplify this?
Factor out h.
Okay, you notice that in the numerator, h is a common factor in all three terms. So I'm going to factor by removing the common factor to all terms, which is a h. I'm using the distributive property in reverse. So I have 6x plus 3h plus 1 divided by h. Now the h's will divide out because h over h is equivalent to 1. And this gives me 6x plus 3h plus 1. Okay, we're going to take a second and put a little meaning to this, because what good is doing something if you don't have a little meaning to it? All right, we had the graph here of f of x equals 3x squared plus x minus 5. And I'm just going to find that f of 1, which is the y value. I'm just picking some points. When x is 1, I'm going to get 3 plus 1 minus 5. 4 minus 5 is negative 1. So I've got a point, 1, negative 1. So a point on this curve, we'll just put it right here, is 1, negative 1. Not exactly sure where it is. Okay, 1, negative 1. All right, then I'm going to pick the number, for example, 2. No, I want to do something different. 3. 3. All right, so f of 3 is 3 squared is 9. 9 times 3 is 27 plus 3 minus 5. So 27 plus 3 is 30. 30 minus 5 is 25. Is that correct? All right, so now I have the point on the curve, 3, 25. Okay, so if you had 2 points on the curve, couldn't you easily find the slope between those 2 points? All right, I'm going to flip the page. Everybody got it? I'm going to put some meaning to what we just did other than just doing it, so you'll have some understanding. All right, so if I just wanted to find the slope of the line between those 2 points, the slope is, of course, a difference in the y value. So I'll say 25 minus a negative 1 over the difference in the x values. That's change in y, 25 minus a negative 1 over the change in the x values. 25 minus a negative 1 is 26. 26 divided by 2 is 13. 13 would be the slope of the secant line between those 2 points. All right, now what's this got to do with difference quotient? Well, what happened is the difference quotient gave me a formula for quickly coming up with the slope between any 2 points on this curve without having to go find every y value. All right, so our formula for the difference quotient, I'll do DQ for quotient, was 6x plus 3h plus 1. All right, that's the formula that we got right here from the difference quotient. Okay, so we studied we looked at when x is 1. Who remembers earlier in the last video how I defined h? See if I still have it here. Wasn't h how far we came over from x to get to the next value? All right. So in this case, with the problem that we just did, what would be my h here? How far did I come over for x? 2. Isn't h equal to 2 here? Okay, so h is equal to 2 because x plus h gets me to that next x value, which is 3. All right, look what happens here. When I use x at 1 and h at 2, it's going to come up with 13, the slope of the secant line. So we have 6 times 1 plus 3 times 2 plus 1. 6 plus 6 plus 1, and there's the 13. All right. What am I trying to do? Instead of just saying, find and simplify the difference quotient, I'm trying to say, really, all you're doing is finding the slope between 2 points on a curve. And when you find a difference quotient, you have found a general formula that if you start with one value of x, and how far you go over to get the next value of x, you just plug it in, and you would not have to go in and find all the y values to get there. All right, everybody good? All right, one last example with difference quotient. I'm trying to hit you with all of the types that you could possibly see in your homework and on a test. That was a quadratic. Last example is f of x equals 1 over x minus 2. We want to find and simplify. The instructions would be find and simplify f of x plus h minus f of x over h. All right, that's called, everybody say it. What's this thing called? Difference quotient. Okay. By the way, what's the domain for this function right here? The domain.
All real numbers except for 2.
All right. The domain is x is all real numbers, but x can never be equal to positive 2. Why?
You can't have a 0.
Can't have 0 in the denominator. Okay. I try to get you to verbalize these things, and then it goes to your long-term memory better. Okay, work ahead of me. What is f of x plus h? What is that? 1 over what? In my problem. If f of x is 1 over x minus 2, what is f of x plus h? 1 over what?
X plus h minus 2.
Yes. Remember, wherever you have an x in your original function, you just put a little parenthesis there. And so if you need f of 3, you'd put a 3 in for x. If you need f of x plus h, you put an x plus h in. Everybody good? All right, and then we're going to subtract f of x, the original function, and divide by h. Okay, who will be first to tell me what kind of fraction this is? It has a special name. Starts with a C. It's a compound, or there's another name sometimes. Complex. Perfect. They're called. That's what you said, wasn't it? Oh, you said something else? Well, I'll give you credit like you knew what you were talking about. Okay, this is called a compound or a complex, depends on who wrote the textbook, fraction. A compound or a complex fraction has a fraction in the numerator or in the denominator or both. All right, so a good review is how do you simplify a compound or complex fraction? What do you need to do? What's the first step? You don't want to do the reciprocal until you do something to that numerator first. What is that? You want to simplify the numerator, and then we'll have division and we can simplify. All right, so we're going to simplify the numerator. Let's do it over here. All right, so I need to get a common denominator between those two terms. What's my common denominator? I can see y'all are going to be up late tonight reviewing the review and the chapter 1.
X minus 2.
All right, suppose your fraction was like a third minus a fifth. What's your common denominator here? 15, correct?
Yeah.
Well, x plus
Plus
h
h
minus
plus
2
2.
is its own little number. X minus 2 is its own little number. What's my common denominator?
X squared plus x.
All right, it's both of these denominators, correct. So it's x plus h minus 2 times x minus 2. All right, that's going to be here's the big division with the h right here. All right, so the first term only has the denominator x plus h minus 2. What do you need to do to it so it also has the x minus 2? Yeah, just multiply numerator and denominator by x minus 2. And what do you need to multiply the last term by? X plus h minus 2, x plus h minus 2. Right? And now I have a common denominator. Okay, let's see if we can write this out. X minus 2 times 1. X minus 2 times 1 is just x minus 2. And what is everybody going to be very careful with this minus right here? To distribute it. Okay, so we got 1 times x plus h minus 2, which we just know is x plus h minus 2. But we have to be very careful to distribute our negative inside parentheses using the distributive property. So we will have minus x minus h. What's the next term? Plus 2. Okay? All right. Now we're ready to clean up. We're always so happy things cancel out. They're additive inverses. X minus x cancels out. Negative 2 plus 2 cancels out. And we have negative h over x plus h minus 2 times x minus 2. Okay, so I still have a compound or complex fraction, but I have simplified the numerator. So the general rule is write the numerator as a single fraction, write the denominator as a single fraction. And once you have a fraction divided by a fraction, what's the next step? Yeah, invert and multiply. So we have negative h over x plus h minus 2 times x minus 2 times, because I'm inverting and multiplying, 1 over h. And when you multiply fractions, do you have to get common denominators and all that stuff? No, when you multiply fractions, you're just multiplying numerators and denominators, so we can just extend the little line here and stick a dot there. When you multiply fractions, you multiply numerators, multiply denominators. And now what are you excited to see? The h's divide out. The h's divide out. So what's left in my numerator now? Negative 1. You still have your negative right here in front of the h, so that's like negative 1 times h. So negative 1 times 1 is negative 1 over x plus h minus 2 times x minus 2. Okay? All right. We had a function, Our instructions were to find and simplify the difference quotient. What happened was we had compound fractions. We had to get a common denominator and simplify. And there we have it. Everybody good? All right, I think those are the 3 types you'll see in your homework WebAssign. Let's take another minute or 2 and let's talk about domains of functions. We're still in Chapter 2, Section 2. This seems to take a little longer than I thought. Let's talk about domains. We've already hit on that just a little bit. Domains. And I'm just going to ask you, we're talking about over the set of real numbers. Over the set of real numbers. X is the element of the real numbers. And when you're given a function and you're asked about the domain, you're looking for all of those values that make this function a real number. And what would you say your domain for 4 minus x squared is? Quickly, that's easy. X is all real numbers because I can plug in any value for x that I want, substitute in any value, and I get a real number. All right, suppose our example is f of x equals 1 over 4 minus x squared. All real numbers except what? 2. What else? 2. Why? Okay. What happens in the denominator when you put a 2 or negative 2 in? Makes it 0. And under the set of real numbers, we can't have division by 0. No division by 0. Okay? What about f of x is equal to the square root of 4 minus x? What's the smallest number you can take the square root of? The smallest number you can take the square root of under the set of real numbers?
Anything greater than 0.
Can you take the square root of 0?
No. I guess technically, but it wouldn't be very useful.
If my debt is $0, that's very useful to me, right? So 0 is a very useful number. What's the square root of 9, everybody? 3, because 3 squared equals 9, right? Because. What's the square root of 25?
9.
5, because 5 squared equals 25. What's the square root of 0? 0, because 0 squared is 0. What's the smallest number you can take the square root of under a set of real numbers? 0. 0. What about the square root of negative 4? No, because there's not a real number I can square that gives me negative 4, correct? So that gets into complex numbers. All right. So when I'm looking for this domain of the square root of 4 minus x, what is the very smallest thing 4 minus x could ever be? 0. So when we're looking for the domain, I find it helpful to say, well, 4 minus x must be greater than or equal to 0. And we know how to solve an inequality. What's the next step? Add 4 to both sides. Oops, excuse me, subtract 4. Okay, so negative x, we're subtracting 4 from both sides, and we get negative x is greater than or equal to negative 4, and what happens next?
X is less than or equal to 4.
All right, we're going to multiply through by negative 1, and you recall that when you multiply or divide through by a negative, you reverse your sign. So the domain is x is less than or equal to 4. Let's check that. If you put a 4 in, wouldn't you get the square root of 0, which is 0? Let's put negative 5 in. Check with x equal negative 5. The square root of 4 minus a negative 5. Is that going to work? Yeah, because you got 4 plus 5 is 9. Square root of 9 is 3. Okay? Everybody good with domains? The 3 examples are, for domains generally, is if you can substitute in any value for x and you get a real number, that's it. You have to watch out for division by zeros. and you have to watch out for negatives underneath the radical. Those are your three cases basically for working with domains. Anybody questions on that? All right, the next little objective in section 2.2, excuse me, is about a 30-second discussion, I think. And then we're going to flip through the pages. And I'm going to show you the book on page 214, pages 214. And this is talking about, I like to call it creating a new function from given functions. Basically, it's saying that if you're given functions f and g, just two old functions like f is equal to x, g is equal to x squared, that if I take two simple functions, if I add them together, I'm just creating a new function. That's all I'm doing, is saying you can take functions and add together and you got a new function. And what happens is the domain for both of those functions have to be carried through. For example, if I were going to add these two functions together with a new function, I'll just call it y. If I add 1 over 4 minus x squared plus the square root of 4 minus x, I've created a new function here. Oops, can't see it. I created a new function here, but the domain for the function 1 over 4 minus x squared still has to carry through, as well as the function x less than or equal to 4. So my domain for this entire function would be x is less than or equal to 4, but you better leave out 2 and negative 2 because that gives me division by 0. Does everybody see how that works? It's just an addition of those two functions to create a new one. Okay, the next part, it says you can subtract functions and you just carry the domains through. You can multiply functions to create new functions. Again, it says the domains come from both of those two functions multiplied together. So instead of adding these two functions, if I multiplied them, I'd still have to worry about the domain with the square root, and I'd still have to worry about division by 0. And then the last one is that you can create a new function when you divide, but you have to go a little extra step here. You got to make sure that what got stuck in the denominator could never be equal to 0, because you can't divide by 0. Everybody good? All right, we're going to go to some of the exercises at the end of the chapter just to make sure we're good, and then we will turn through the pages and make sure I did cover every single thing that I was supposed to in section 2.2. Okay. The first one that we're going to look at is page 217. This is kind of our cleanup. We're going to look at problem number 82. Similar to some of your homework questions. Let's see if I'll read it to you. Number 82. Is that good? All right, it says, if f of x is 2x minus b over 3x plus 4, and we're given that f of 2 is equal to a half, our instructions are to find what is the value of b. What is the value of b? What's this information right here? F of 2 equals a half. What does that tell me relative to this problem? How are you going to use it? Where am I going to put the 2?
Substitute it for the x.
That's a substitution for the x. Where am I going to put the 1/2? That is your y value, correct? Y is your f of x. So this says there's a point on the curve of this function. It's the ordered pair 2/2. And if I go plug it in here, then the only unknown that I have will be b. So when you have a problem out of the textbook, you know, instead of just reading through it, say, what is that telling me? How does it fit to that problem? Okay, so let's do this one together. Number 82, we're told that f of x is equal to 2x minus b over 3x plus 4. And we're told that the value of the function at 2 is equal to 1/2. it means that the point 2, 1/2 would be on the curve of this function. All right, but our instructions are to solve for b. And we know the x value is 2 and the y value is 1/2. Y is a function of x. So let's just plug those in. We have 1/2 equals 2, and in the place of x, I'll put a 2 minus b over 3 times 2 plus 4. Everybody agreeing with that? We have 1/2 equals 4 minus b over 6 plus 4, or 1/2 equals 4 minus b over 10. What's my goal? Solve for b. I've got a fraction equal to a fraction, and I'm solving for b. How are you going to solve this? Okay, you'd notice that that denominator was a 10 and this was a 1/2, so you knew the numerator had to be equal to a 5 because 5/10 is a 1/2. Okay, that's great insight. Let's pretend that you didn't have any insight. What would you do? Okay, you are going to do the golden rule. Multiply both sides of the equation by the common denominator. Do unto one side of the equation as you do unto the other. So you're going to multiply both sides by 10 because that's the common denominator for 2 and 10. Is that what you said you were doing? All right, so 10 divided by 2 is 5. 10 divided by 2 is 5. The 10s on the right cancel out because they're multiplicative inverses. And we have 4 minus b. Subtracting 4 from both sides, we get 1 equals negative b, or b is equal to negative 1. Let's see if that works. If b is negative 1, 4 minus a negative 1. Let's do our little check right here. Check. 4 minus a negative 1 over 10. 5 over 10, and that reduces to 1/2. Okay? All right, I was wondering if somebody was going to tell me we're just going to cross multiply here. Anybody want to talk about cross multiplying? Apparently you didn't. But when you have a over b equals c over d, and there's no way that b or d could be 0. You can only do this if you don't have any variables here that could possibly be 0. Then you could, some people like to cross multiply. They go AD equals BC. Okay, and then solve from there. But multiplying through by the common denominator due to one side of the equation as you do into the other is a very good thing to do. All right, does this make sense, everybody? You were given a function and you were given information about this function. You were given a point. And you were able to substitute in and solve for the one unknown. Questions? Easy? Okay, let's look at the next example, number 86. I'm helping you with your homework. Hope you noticed this. Number 86. Let's see if we can focus in. There we go. Number 86, express the area A of, what kind of triangle is this? Isosceles and what else?
Right.
Right. An isosceles right triangle. What's an isosceles triangle?
Two sides are equal length.
Two sides have the same length, or there's two angles in it that are the same measure. Okay? And what's a right triangle? It has a 90 degrees. So we're going to have two sides of the same length and we got to have a right angle. As a function of the length x of one of the two equal sides. Okay, so they sort of told you there were two equal sides there for an isosceles triangle. All right, so let's draw our right triangle. This is number 86 on page 217. A right triangle, so we've got to have a right angle in it. This is my right angle. And if it's isosceles, it says one of the, what's this line right here called? Hypotenuse. And these are called the sides of the right triangle. And it said the sides are x times x. Okay, in general, what is the formula for the area of a triangle? 1/2 the base times the height. Okay, so for our triangle, it's 1/2, and what's the base length? X. And what's the height? X. And so we might write that as x squared over 2. Trying to review you of some of your geometry. And see, what we have here is a function. Did you notice that? The area of this triangle is a function of x, where x represents the sides of the right triangle. So area is a function of x, where x is a side. So you came up with a function. Okay, let's look at problem number 98. Where is that? Oh, I like problem number 98. This book is really good to have a few discussions going on. Problem number 98 says, are the functions f of x equals x minus 1 and g of x equal to x squared minus 1 over x plus 1, are these two the same function? Are these two the same function? Let me say yes. Raise your hand high and be proud. Let me say no. Raise your hand high and be proud. Does that mean the rest of you don't know? Why do they look almost the same?
Because it's x squared, and usually you can factor it, but it's x minus instead of plus.
Okay, the x squared minus 1, you know how to factor that to the difference of two squares? Doesn't that factor to x plus 1, x minus 1?
Yeah, and so these would
And they
cancel
cancel
and
out? Okay.
But-
But what?
It didn't work in my head.
That worked.
Okay, so are you going to say they're the same? Okay, we're looking at number 98 on page 218. This is just a suppose. Suppose I gave you the function f of x equals 1 over x plus 1. What would you say your domain is here? Just suppose I gave you this function. What's your domain? Okay, the domain is x is all reals, but x can never be equal to negative 1, right? Suppose I give you the function g of x is equal to x squared minus 1. What would you say your domain is for this? All real numbers. Okay? Now, if I say that I'm going to use our little theorems that we had back here, the quotient, f over g, is the function defined by two separate functions. The domain consists of all numbers x for which the denominator is not 0 that are the domains of both f and g. The domains of both f and g. Do you see where I'm headed? If you're not, wake up. All right. So if I put both of these together, and I'm going to do a g of x over f of x the way I wrote it. So if I get the function that's right here, I'm going to call that a h of x. It's a combination of these two. X squared minus 1 over x plus 1. The theorem said that when you take two functions and you put them together, you still got to carry the domains of your other functions. Isn't that what it said? So what's your domain here?
All real numbers except for negative 1.
Okay, your domain is x is all real numbers, but x can never equal negative 1. All right, now let's get everybody get with me. Let's go back to the book. Are the functions f of x equal to x minus 1 and g of x the same? How many say no? Tell them why.
Because the domains are different.
They have different domains. So these are not the same function because they have different domains. F of x equals x minus 1 is a straight line defined for all values of x. G of x, does anyone guess what that graph looks like? Because it does simplify down to x minus 1, but what happens? X can't be negative 1. So what's the graph of this thing going to look like? Let me say it again. I want you guys to get this because actually you need this for your calculus course. G of x, which is x squared minus 1 over x plus 1, that factors, and this divides out, it simplifies down to x minus 1. But you have to remember that your domain is that x can never be equal to negative 1. So x equal to negative 1 never exists. So what is the graph of this function going to look like? What would be this graph? What's the graph of y equals x minus 1?
Horizontal.
Y equals x minus 1. What's that graph?
The line.
Line. What's the y-intercept?
Negative 1.
Negative 1. Slope is positive 1. Okay, so here's that graph. But what did that domain tell you you better do?
Can't be equal to
You better leave out where x is negative 1. So you're going to put a big old hole in it where x is equal to negative 1. So this function, because it has a domain x can't be negative 1, even though it simplifies down to the line y equals x minus 1, wherever x is equal to negative 1, you've got to put a hole in your graph there. Okay, so do you see why those two functions are not the same? X minus 1 is a straight line with no holes in it. G of x, because it simplifies, is a straight line x minus 1, but it can't be defined at x equal negative 1, so there's a little hole there in your graph. So the answer is no, these are not the same functions because they have different domains. You've got to look at the domain before you start simplifying the function. Everybody got it? Everybody good? Okay, let's quickly flip through the book and then we need to call it a day. Make sure we got everything covered. You're an expert now in Chapter 2, Section 2. At the beginning, you had to determine if a relation was a function. And you know for each value of x, there can only be what? One value for y. What does it mean to find the value of a function? You put in that value for x and get out a y value, the value of the function. What does it mean for the domain of a function? You're looking for what values of x give you a real y value, a real number y value. And forming the sum, difference, product, and quotient, you're just taking two functions. You have to carry through the domain, and you've created a new function. Be sure you're reading through your book. On page 206, it gives you the definition for a function. X exactly gives you one element of y. There's your terms, domain, and ranges. Has some very nice examples in the book to read through and practice. The value of a function, f of x, the value of the function at the number x. Lots of great examples. Your domain is often called your independent variable, range dependent, because you put in a value for x and your y value depends on that. I used the word explicitly earlier. Y is expressed only in terms of numbers and x's. I forgot to mention implicit form. That's where you got x's and y's all mixed up. Implicit versus explicit. And then the rest is finding domains. So you are in great shape for section 2.2. And I look forward to seeing you tomorrow. Make it a great day.